Hi, how are you all? Myself, I am Nitish Kumar. Today we are going to start the new chapter in physics, that is fluid mechanics. This is one of the most important chapter in the point of view of JEE mains and NEET point of view also. Okay, let's start the chapter. The topics which we are going to cover in this lecture is, first one is just introduction of fluids. Introduction of fluids. And another one is, we will discuss here pressure and variation of pressure. Variation of pressure vertically with depth. Okay, vertically with depth. First we are going to discuss about fluid. In this chapter mainly we are going to discuss fluids in three parts. Okay, first one is static fluid, second one is dynamic fluid, and third one is viscosity. This is very important, viscosity, so that I have written with another color. Okay, first static in the sense when the liquid is at rest, then we will study the properties of fluid. And this dynamic fluid means we will study the properties of fluid when the fluid is in motion. When the fluid is motion, then we will study in the dynamic fluid. When the fluid is at rest, not moving anywhere, then we will study the properties of it. Okay, that's all about static and dynamic and viscosity. That is another big topic, very important also. Okay, next, fluid. Here fluid in the sense we know that we will call fluid as gases and liquids. We will call gases also as a fluids, but here in the chapter we'll just only discuss about fluids. In thermodynamics we will discuss about gaseous. In this fluid mechanics we'll just discuss about liquids. And this fluid also, ideal fluid. What is the difference between general fluid and ideal fluid? If they are two external properties, there will be two more important properties. That is, first one is incompressible, and second one is non-viscous. Here incompressible in the sense when we apply the pressure, then there will be no change in volume, mass. If there is no change in volume and mass, there is no change in density also. Okay, when incompressible means when we apply the pressure on that fluid, if there is no change in the volume and no change in mass and no change in density, then we call it as incompressible. And non-viscous. And another one is non-viscous. What is non-viscous? Non-viscous is nothing but no tangential force. What is tangential force? For example, if you take two liquids, I have taken two different liquids, and if there is no tangential force, means there is no force along the tangent. For example, there is no the force along the tangent, means in this direction or in this direction or in this direction, if there is no force, in the sense that is literally directly called as friction. There is no, we can say it as there is no friction. That is called non-viscous. No friction. No frictional force is acting on the two fluids. Then ideal fluids only we will discuss here, but not all fluids. Okay. Next we are going to discuss about pressure. Going to discuss about pressure. Okay. Pressure, and we know that pressure is a scalar quantity. Pressure is a scalar quantity. We didn't mention, or we cannot determine we cannot say that pressure is applying on this particular direction, so that it is scalar quantity. And what is pressure? Pressure is nothing but F force upon area. Here it is not just a force, it is perpendicular force. It is perpendicular force upon area. What is perpendicular force? I will discuss that. Okay. For example, if you take this is the liquid surface, and from this direction a force is acting. From this direction a force is acting, and the angle is theta. Angle is, wait 1 minute. The angle between them is theta. Then we know that how to make the components of the theta. We learned in vectors. That is, and the side which is adjacent to the theta, that is f cos theta. F cos theta, and this will be f sin theta. This will be f sin theta. Here perpendicular force is nothing but we will take only this f cos theta force, but we will neglect this f sin theta force. Means here what is pressure? Here pressure is nothing but f cos theta upon area. We will not consider here f sin theta. That's it. Okay, next it is a isotropic. It has another one property, that is isotropic. It is isotropic form. What is isotropic? For example, if you take this is a container contained liquid, and here for example this is a point P, and here if you apply the pressure on it, then the pressure will be applied in all directions. The pressure will be there in all directions in the sense all 360 degrees directions. This is nothing but isotropic form. Okay, and the units of pressure are force upon area. Now force units are Newton, and the area units are meter square, Newton per meter square, and this is also called as pascals. And 1 atm is equal to 1.013 into 10 power of 5 pascals. Okay, 1 atm is equals to 1.013 into 10 power of 5 pascals. Here atm also is one of the measuring unit. For pressure. And next one bar also measuring unit of pressure. 1 bar is equals to 10 to the power of 5 pascals. There is literally we say 1 atm is equal to 1 bar, but there is small difference, that is here 1.013 and here just 1. Okay. Next, variation of pressure. Okay, variation of pressure. variation of pressure. There will be two variations, that is with depth and with horizontal. In this class we'll just discuss about the pressure vertically with depth, not horizontally. Vertically we will discuss today. Okay. See, first example, if you take a beaker containing of water, okay. Here the pressure at this point, think all of the pressure at this point is, let us assume P naught. This point is assume P naught, and density of this water, is rho. Rho is the density of water. And next we have to find the pressure at this point. How we have to find the pressure at this point? Means the height between these two is h. The height between these 2 points is h. How we can find that? For this, let us assume a cylinder. Okay. Here I am drawing the cylinder outside. I am drawing a cylinder. Okay. These assumptions are very important in electrostatic chapter also. Okay. Okay. Here a liquid is there inside of this. Okay. And here at this point the pressure is P naught. This point pressure is P naught. We know that force pressure is equals to force upon area. Here perpendicular force, directly I am writing. Force is equals to P into A. Here pressure is P naught, so the force is applying downwards, that as P naught into A. This is F. P naught into A. And at this point, let us assume, and downwards there will be gravity, that is mg, and here let us assume here the pressure is P. Here at this we have to find the pressure at this point. Let us assume the pressure is P. So the force is upward direction as PA. This is force. So we have to find this pressure. We know that the vertical force and horizontal force are equal. So P naught A, these two are downwards. Okay, P naught A plus mg is equal to PA. Okay, and m is equals to, we know that mass is equal to density into volume. So just let us substitute that, and we know that volume is equal to area into height. Volume is meter cube, meter square into meter cube. That's it. Okay, just substitute that. PA is equal to P naught A plus mg, and this A get cancelled. So P is equal to P naught plus mg. And here mg can be replaced as rho of AH into m can be written as rho of A into H. So P is equal to P naught plus rho GH. Here A will be cancelled from this. Yes, okay. that this is a final answer. The pressure at this point is P naught plus rho GH. P naught plus rho GH. That's it. We can do this is a variation of pressure with downward, variation of pressure with vertically with depth. Okay, I think all of you understood these topics, and if you have any doubts, please ask me in the comment box, and if you like this video, please hit the like button, and thank you.